Great. Hello, everyone. Welcome to today's workshop. Today, we are glad to invite two co-founders from Neo Research to give us a workshop about NeoCompiler. Hello, Waiter and Igor. You can have a self-introduction first, then you can start your workshop now.
Okay, thank you, Sam, for the invitation and the hosting of this workshop. My name is Igor. I'm one of the co-founders of Neo Research community, and I'm currently professor and researcher in computer science. So I think Victor can introduce himself as well.
Hello, Sam. My name is Vitor. It's a pleasure to participate in these workshops. I have been seeing the online videos on YouTube, and I saw good classes and good teachings regarding Neo tooling, and we are here today to contribute in this line of reasoning about how to use Neo tooling. So, a part of introducing our NeoCompiler ecosystem, we're going to show you an easy way to compile, deploy, use a wallet, integrate a wallet with dApps, and we're going to show that with our simple app that can run online, can run on Visual Code, can run on your local computer, or can even be standard to create shared networks. So it's a pleasure to be here today. Thanks for this invitation.
Okay, so this is September 5, 2023, just to record for the future people watching this video. So this is a quick overview of what we are discussing today. We'll be passing a brief history of the project, the Compiler Eco project. So we will also discuss a little bit how is it structured. We will show some successful use cases for this project. We'll demonstrate how to use it, show some options. We have several options on how to use it for develop smart contracts on your blockchain. And finally, we'll do some hands-on. So this project, it started on December 2017. But officially, we have launched the server only in 2018. And at that time, the idea was to support the development of smart contracts in Neo with this online compiler tool. So at that time, the idea was just to simplify the process of installing some compiler and testing some smart contract. Some people had some difficulties like in installing the tools, and I think in other blockchain projects it is also common to support some online tooling, especially when you are, we have did some demonstrations at the time when you are on the beach taking some beer, and then you open your smartphone and then you can code like some very nerd stuff. But I think it's useful, like especially for teaching purposes and to attract more people to the project. When you have an easy way to demonstrate how it works, I think this is a very important thing. We believe in that. And so the first version of this project was very simple, and we have a picture here on the right, the Neo legacy version of the NeoCompiler Eco. And at the time, it was a very wide screen, like we only had a box to support compiler, and then we had help from many people in the community to start putting, some colors, some code highlighting, then a lot of tools. Then we started to build like the left part of the white screen with a lot of options. At the time, it was like it was not planned. We just people required some new tooling we put there. So I think the hackathons at that time helped a lot to shape what is the tool today. Like many people needed help, like to watch storage from contracts. Then we supported some private net, and then it began to grow as a very complete tool to support blockchain explorers, to support the whole process of developing a smart contract. So nowadays, we have this left screen here that is much more well built. Like the project was rebuilt from scratch for the Neo N3. And then, so I think regarding design and tooling, the idea is more or less the same from Neo Legacy to and the Neo N3 version. We also support some tooling for developing consensus technology. What I think is one of the most important things of this project too. And then, so we will show a little bit how to use it. Do you want to add something in the slide? Okay.
No, I think that's it, Igor.
Okay. So the general overview of the project is that it is hosted on GitHub, so you can go to GitHub/new research/NeoCompiler Eco. Then the project is completely open source and is based on microservices, especially Docker technology. So the idea is to mainly support the compiling stuff. Like the idea is to support all existing compilers for a new project, and it's an open source project. So any new thing that arrives, it's easy to plug there. We just built a new Docker image for compiling, and it's fine. So you can add this to our compiler services. So we also support emerging technologies regarding blockchain. For example, if one wants to try a new consensus algorithm, support new technologies like oracles, we are working on supporting decentralized file system technologies as well. So anything that arises in the community, we want to add to this platform. Because it's a way to disseminate how to use this in an easy way and also integrated way. So we guarantee that everything will work together, and it's very simple. Again, in the next slides, we will show the ways to use it, but I advance in a little bit. The easiest way to use it is to open a website and use it, but we have many other ways to use it as well. And then we also have some modules for didactic stuff and learning, like some examples. So you can open some programming examples of Neo contracts. We also have some modules for conversion of data. When we deal with blockchain technology, that is a emerging technology, sometimes we need to deal with bytes, some very deep stuff. So we try to make this simpler by providing an easy way for users to explore this without needing to code everything. Of course, when you're building a complete app, you need to code, you need to build some backend service, you need to build some front end for your app. So, but for early phases, we believe this project can help people to start some projects, to learn how blockchain works. At least this is our experience on the field of blockchain, to teach this. We find that students find this really easy to use compared to other existing projects. Some successful use cases for NeoCompiler Eco. We have some heavy usage for teaching blockchain. So there's some QR code here for some paper we have published on using blockchain for teaching in Brazil. And then this project has been used a lot in hackathons. So an easy way to do this for hackathons is to use our website, the NeoCompiler.io website. But since this website can be slow sometimes, or can be, I don't know, this is a very shared resource, like worldwide shared resource. For hackathons, it's a good practice to host some on-premise version of this platform so you can use it privately for your hackathon. But some people have asked us to use, like this, the public instance. And since this instance, it reloads from time to time, it's something that's very stable, even though it's a worldwide platform. We have developed some recent applications of this platform using Gitpod. So now it's very easy to launch a particular instance, a personalized instance of NeoCompiler Eco. So you just click the button, and we will show you how to do this. You click, and then you have your own instance of this platform. It's very good because it's very easy to do. You just click. And you have some time to use this on Gitpod. So you have some free hours, usually monthly hours on Gitpod. But if you want to use it locally on VS Code, we also developed a very local and secure way that uses the dev containers plugin for VS Code. We will also show how this works. It's very easy too. You just rename the folder that's already prepared for that. And the good thing is that it's very secure. It supports Docker rootless mode. That's very safe mode. And we also have been using this platform for teaching. So there is another QR code here of a paper we have published on Future Internet Journal on using consensus for blockchain, developing new consensus for new. And then we used a lot of the platform for debugging and for checking how this consensus works, if it's stable, what are the flaws. So we have using this platform for this. We can also use the platform for developing new operations for new backend, like some SDK operations. And you can also use this for you doing opcode optimization. So we have historically offered many possibilities for users, like to optimize the opcodes, to inspect the opcodes, to understand how it works. And we are putting all this from Neo Legacy to Neo M3. So the ways to use it. The easier way is to just open the link like neocompiler.io. Then you can do it on a smartphone or a computer or on anything that has some internet access. It's very easy to do. So I think this is like the easiest way to demonstrate to someone how Neo blockchain works. And it's very easy. In 1 minute, you can show how our smart contract works, and you can invoke the smart contract. We have an integrated wallet system, so you have some money there. Is of course some fake cryptos because it's not the mainnet. But it's interesting that the new compiler works also with the mainnet and the testnet. So you can really interact with the mainnet. You can really put funds there. We don't incentivize people to do that because it's not built for mainnet operations dealing with real crypto. But some people do that, and so when doing that, we believe that's more secure to host the software in your own computer, so you have greater security. But it's possible to do that. And for teaching, we host an instance of the NeoCompiler Eco in our own servers in university-based on-premise hosting. This is for teaching, so because the students use it a lot, so it's good to have some dedicated instance. We also have tested some inter-university interoperability applications with NeoCompiler Eco. So we host some consensus nodes in one university and other consensus nodes in other universities. And this is good to provide studies on blockchain governance. How can these institutions maintain a common blockchain? Now we talk a lot about state-based blockchains, and Brazil is building some Brazilian version of a common blockchain using private blockchain technologies. And we are also big incentivers of using Neo in Brazil. So we believe that Neo blockchain is very useful due to its PBFT-based consensus. It's very good to host it in public and also in permissioned blockchain scenarios. So the platform is very useful and very easy to do that. We have some scripts to configure this cross-chain activities. And it's easy to do to code on a smartphone. We don't incentivize people to code on a smartphone because it's not practical for big contracts. But it's nice to show small stuff, to test small stuff. It's very easy to do. So you can do this using internet access, like to some public instance, or you can host your own instance and use some VPN to access this instance. We believe that this on-premise hosting can sometimes be less stable than doing locally on your computer. It's much stable, much faster. And we have there's some possibility of overloading. If everybody uses it at the same time, you can have some starvation in these processes. So we also have some shared private net resources, so the blocks can become slower. So sometimes it's better to have your own instance. So we go to this Gitpod strategy here. It's very easy. You just go to GitHub of NeoCompiler Eco, and then you click the button open in Gitpod. It will open a private instance for you. So we believe this is the best way to use it nowadays. And you can also scan this QR code that it will automatically open the Gitpod instance for you. The Gitpod gives 3 hours of development. So after these hours, maybe you need to pay some extra hours. Or you can just migrate to some local development. Some people like to do it locally. Personally, I like a lot to use VS Code to code, Visual Studio Code. And I believe the easiest way and secure way to do this is to use the Dev Containers plugin that allows some greater level of isolation. So it opens like a VS Code inside your own VS Code, so it's very isolated. And it also works fine with Docker rootless mode. There is a version of Docker where you don't have root access. We believe this is also safer. And some projects require it to be rootful, but in our case, no, you can do this rootless without a problem. And it works automatically. You just we have some scripts that detect that your Docker is already rootless, and it works fine. So it's also one click launch with the containers plugin on VS Code. We can demonstrate that too. And finally, if you don't want this isolation, you just want to open it. So it's the project works fine on Linux. You just execute the script, build everything. It will build all the images from Docker, all the compilers, all the local network, all the consensus, all the Oracle nodes, everything. It will take some time to build everything, but it's a local instance that you can do on your computer. It also works on Windows WSL, this Windows subsystem for Linux, and some people use it as well on Mac. So finally, we have some hands-on. We will demonstrate the interface, some basic stuff on the NeoCompiler Eco. This is not a very complete tutorial. It's a lot of things that we have on this platform, but we can briefly demonstrate this. So we have a QR code here if you want to scan it. And Vitor, do you want to demonstrate this part?
Yes, thank you. Thank you, Igor. Thank you for this introduction. And until now, you were able to understand why we created NeoCompiler. And as Igor explained, it has been used on Neo 2 by most of the developers of Neo ecosystem. Not because of the compiler itself, but because of its set of tools. We had simple conversors, where, as Igor highlighted, we even used NeoCompiler a lot during the development of DBFT 2.0.
Vitor, just 1 minute. Can you open the Gitpod instance because it takes some time? So we can.
Yes, sure.
Yeah. Yeah.
So
I
let me
can-
share my screen.
Yeah, because it takes some time to. We will start from scratch here.
That's a good
So-
idea, yes.
We hope it works, like practical demonstration.
Desktop. Can you see the
Yeah,
GitHub?
good. Yeah,
Okay.
I see your GitHub.
So this
GitHub.
is the GitHub page of NeoCompiler. Here in the README, you can click on Open Gitpod, which would be the same as scanning the QR code Igor showed. So we click here, Gitpod will ask you for set up the machine. Let's pick the standard one.
So this is for those who are not used to Gitpod, it opens like some editor, like online version of VS Code, Visual Studio Code. So it's a very practical way to, especially to demonstrate technologies that are complex projects like this one, that has a lot of things. So we configured the script to, as soon as you open Gitpod. So this is the good thing of demonstration is that
Sometimes things not work. I think right now Gitpod was out of internet, so the script it calls first it downloads a client, but here it said that the download was not possible. So the first time it happened, so I'll just run this command again, which is build everything. I hope Gitpod has internet access now.
I'm also opening my instance here with, so it will serve as a backup.
First by timeout. I think I will create another workspace. Maybe my workspace had some issues. I think I'll try to create a new workspace.
Oh, this is really funny because mine also broke.
Also broke. It's
Also,
internet problem from Gitpod, I think, Igor. I think
yeah,
we can just skip Gitpod for now. I'll show the
yeah.
online version.
Good. And we
I
keep
think so,
waiting
because
till it
I
loads.
think we cannot solve this. It's trying to download. It has been working. It works. But since it's a service, Gitpod provides us a virtual machine. I think this virtual machine they are providing now, unfortunately, has some issues with internet. Oh, no. Oh, this other one went through. I open a different, it's the same. I just open a different container.
No, the internet is now back, Vitor.
Oh, it's back. Both of them are working. Okay.
Yeah,
I'll just
mine is
stop
also
one
working.
of them. This one I will stop.
Some quick instability.
Some quick instability. No, but Gitpod service is good. It's the first time we had this issue.
Yeah.
So
Maybe
meanwhile,
you show the line. Yeah.
Here, while it's just downloading and create some Docker containers, I will just show you what's going through in the background. It's basically this. Images are being created. For example, the C# node. Soon this will be fulfilled of images. So meanwhile, I will show you online. Here we are in the online version. It's a shared network. So in this shared network, sometimes it's reset. It's not a test net. The test net usually it's maintained like the main net. Here it's not. Here it's like a network for teaching, for hackathons, but it's shared. So in this simple editor, you can compile contracts. The idea is that you click compile. It's calling some remote compiler. We're gonna wait for this compiler. Here you can see native contracts that are created when you set up an instance of a new network. These are the basic native contracts. They are natively created in the Genesis block. So the code, this simple hello world has been compiled. What happens here? When you compile, it starts to be cached in your browser, so you can deploy it. But if I click here to deploy, there is no wallet. Okay, so first we need to connect a wallet. When you click connect, it first asks you, want to try to connect some external wallet like Neoline, O3? Here in this browser I am using right now, none of them is available, but I can open Neoline or I can open O3 and they will appear here to be connected. But this will lead to the next step. Let's use the first basic features first. So no API will try to be connected. So let's connect the mood signature. The mood signature is the wallet of the new nodes. Let's connect this mood signature wallet. So every time you sign a transaction, all the private keys of the nodes will help you to sign this transaction. So you will this wallet do all the operations as a mood signature. So let's deploy this hello world. Here,
and this wallet, wallet has a lot of coins also, Victor. But just to enforce that these coins are only valid in the private network. So these coins are not real coins.
So as you can see here, in this activity, the hello world created a transaction. D010, which is this one here. The contract has been deployed. So it will appear here as a deployed contract, and you can invoke its functions. You watched the other workshops. I think you are kind of familiar with smart contracts, but I'll just show you here some basic call, which is to get the storage. When you deploy this contract, you create a storage with the key hello that's stored world. So we're going to call my method. The good part of this online tool is the simplicity. Even the user interface is not perfect, not beautiful as we would like to. As you may see, it has some things that helps the first contact with new blockchain. Even for expert developers. We heard about other developers that use it. They give classes, they even use on daily activities. So for my method, you just click here. It doesn't have any parameters. You invoke the function and you can relay. So it's relayed. It will appear here.
Yeah, and before we relay, you can also see some tests on the transaction. Yeah, even without relaying. Yeah.
This was here you can get the log of the relay transaction by clicking get transaction is the raw transaction you send. This is your whole invocation. As you may see, since it's a mood signature, the witnesses are huge. This size of witness are not common. This is because it's a mood signature. In the second example I'll show you, we will try with a simple account. You can get the log here. So as you may see, it returned something, this byte string.
Yeah, this is some base 64 encoded string.
You can come to this conversor.
So we have these conversors modules. That is very easy. So Victor used some base 64 to hex, then from hex to string. So you can see the text world.
So perfect. This example, this is the basic hello world of several blockchains. Several programming languages have this hello world. In the blockchain world, most of the systems creates the hello world with a storage. This is the common way to create a hello world in the blockchain space, is to store something and get it back. I will close the online compiler. We'll move back to Gitpod. As you may see here, we're going to have all the images already created. Let's see the other consoles, if it really finished. So the Gitpod asks you to open a page, which is the front end. I click it here, the front end will open. Our network is already with 180, almost 200 blocks. And the same functionalities as before. You can change network here. You can go to a local network, to mainnet. You can go to that private one. So what we're going to do here, we're going to run an Oracle example.
It's also interesting, Vitor, to show that this blockchain is very fast. Like this is like 1 or 2 second network. It's really fast. So you just click and everything happens. So it's very good to test things.
You can monitor here the network. You can see blocks are created every 2 seconds, every 1 second. Oh, this Oracle example, it's like the hello world. But what we're gonna do here, we're gonna call some external URL, some external HTTPS website. From this website, we're gonna filter the data and we're gonna filter a specific field of this JSON. This field can be treated here and you can store on the blockchain. But this part we're gonna not do now. We're gonna just invoke a transaction and hopefully it will work. So we're gonna compile this contract. The compiling time here depends on the Gitpod machine we are using. As you may see, it was quite quick. This is the created script of your deployed contract. So it will appear here as well, cached. We need to update these names. It could be like Oracle cached. It's a standard, template C#. So we connect this wallet. What we're gonna do now, let's transfer all these funds to a first wallet. Let's say Echo 1. So let's transfer some new. Relay. It's here. Let's transfer some gas. Just a little bit of gas. 100,000. Okay. So we can do everything now with an arbitrary single account wallet. Let's connect it. So deploy this contract with this wallet. It has been deployed. These were the first to send. This first transaction was send new, send gas. Now the contract has been deployed. So right now, what we need to do before is to elect the Oracle, because the Oracle is still not working. We're going to elect the Oracle. So the Oracle is now running. And we can invoke an arbitrary website here. Which website we're going to invoke? We're going to invoke our compiler's RPC. Let's get the basic echo. Is this one here? I want to invoke this compilers. This page returns a JSON which say result is true. We have the complex. This is the standard RPC for compiling. So let's invoke it. We're gonna pass this URL as a parameter of our Oracle contract. The field we're gonna filter is result, which would return true. And the amount of gas, there is a minimum gas, but it's in the power of 8. So I don't remember precisely. I know that this number won't fail right now. So invoke, it did not fail as expected. These are the parameters we passed, né? The filter, the destination, the amount of gas, okay. As you may see, it's not a lot of gas. It's like 0.6 gas, but I think it could have been less. Let's deploy. Okay. Now the interesting thing. Let's come to the oracles and see if it's processed. I think the RPC node is the oracle. The oracle here is connected to the RPC. So since I think the Gitpod machine is a little bit, has not much processing power, so these two nodes here are stuck. I'm gonna reset them manually to see if they come back.
I think your machine is very slow. Mine is not lag behind.
I think I should pay a better plan. Let's connect. Let's go to the RPC. Here you can list all the nodes you are running. The RPC node, we're gonna go inside it. RPC dash. Behind. I'm gonna queue it. I'm gonna start it again to see if it will resync. Resynced. Oracle response is here. Look, success. Here we are. Success. Okay, it got the JSON we wanted. So the response was true. Let me zoom in. The response was true. It got the JSON and it filtered. Because in fact, the filter is something related to the callback. The callback filter and process this value, and you could have passed to another smart contract, you could have stored. And an interesting thing here is that you can filter these transactions. So let's come here to a simple filter. Let's say we are here on the block 500, on the block 535. I want the last 200 blocks with minimum of 1 transaction. So what you're going to see here, look this amount of time it took to process the Oracle request. In fact, my transaction was this transaction here, 0x82. This was the request I made. This was the transaction. I sent the destination, I sent the filter, and I request, please Oracle, get this value. But my node was down. Do you remember? So we have almost 1 minute difference here between the request and the Oracle response. What is the Oracle response? This one. Look, the Oracle response is 0x3f. Let's click on the Oracle response. What we have here? The Oracle response. What's the Oracle response? It's a byte string. But who is this byte string? Let's come back to conversors. We have this hex. Let's revert this hex. Look, the Oracle response says that it is a response from this transaction. 82, 0x82, that finishes with 0AF1. Aqui, ó, 0AF1, 82. The Oracle response gives you the transaction it responds to. Let's make this call again to see that usually it's faster. So I'm going to prepare here the function. The function is just created. If you agree to sign, if you were connected to O3 or Newline, when you click here, sign and relay, that would be the point when you would be asked, do you want to sign on Ledger? Okay, that would be the point. So we come here to the Oracle service. Let's see, my node is not. No, okay. So let's filter the transactions again from 610. Oh, this time was quite quick. Look, my transaction was 081. In the next block, we had the Oracle response. The Oracle response related to that transaction. Aqui, ó. 81 finishes with 786. 81. Okay, that's it. So this was the Oracle example running on a instance on Gitpod that was quickly set it up with some minor problems, but that's it. That was the first step I planned to show to you. Do you want to add something, Igor?
Yes, I think I can quickly show on VS Code the dev containers. So, okay, so another option, a third option for you is if you want to test locally, you can just download the project and in your computer. So here, can you see it? Your no sound.
I can see the dev container.
Okay, good.
Okay.
So this is a VS Code, Visual Studio Code extension. You can see here that I'm connected to some remote container. So this green part here means I'm in a VS Code inside some VS Code. So the configuration we provide here is some dev container template. I'm just copied it on dev container folder for me. So this is the same. What we do in this this instance here, you have some image, some base image. You have some. This is provided from dev container community on VS Code. So this is a very standard Docker image. This is called Dude, in fact, because this is Docker outside of Docker. And we have also some dind, that is Docker inside Docker. But to work with dind, you need some more permissions. So Dude is usually easier to do. The thing you need to do is to share your sock from Docker. So this is some configurations to share the Docker from my computer to my Dude instance. This is done automatically. What we do, and the project creates some eco password, not password, the path here. So this is, the real path in my computer. We need to share the Docker sock because like I said, you cannot have a Docker inside Docker without greater permissions. But as soon as you do this, the process is the same. You just run the script, the build everything, and everything will be built. And my image is already working here. In fact, it was already working. I'm stopping it. So, okay, now I'm removing it to add it again. So as soon as it finishes, it will open some browser. And it's not different. It's the same as all development. Victor showed in Gitpod. I think an interesting thing to show, so this is, I will stop here my VS Code because it's the same. But in fact, there is a small thing that we want to show that in the future, we plan to explore some possibilities. For example, to integrate this Visual Studio extensions, for example, to create some basic extension for NeoCompiler Eco so that the user can actually use the VS Code and connect to our compiler service and everything we also provide already. So maybe users are already familiar with the VS Code IDE, so they have maybe they want to have their local compilers for some language or not for the others. There are many possibilities. Maybe they can use this for debugging, and also we can benefit from other tools from community. We have some great tools for debugging that other Neo communities have developed, and we believe that the path for having greater experience for users is to provide users with the possibility to use everything that everybody is providing. So this is another way to use this platform. Right now, I'm going to stop my transmission here. Let me stop it here and go back to slides. Let me share my slides again on okay. Oh, my browser now is not working. Can you hear me?
I can hear you. Yeah, your browser it's on now. I can see your
Okay.
browser.
Okay, good. Okay, so our final slides here. What can we expect from this project? We believe that this project is very important for the ecosystem. It's an easy way to access all the possibilities that Neo blockchain offers. So it's an easy way to code a basic smart contract, to interact with a wallet. So it's very useful to teach people in many aspects. You know, what is a wallet, what is some address, what is some account, how the blockchain works, some details. You can teach how invocation script work, how verification script work. So you can have some basic explorer stuff. So we believe that some future for the project is to have more integration with VS Code. What we did with Gitpod is a way in this direction. So we believe we can have more of this. We can have greater integration with other products that exist on the ecosystem. We also can support some tools that existed before on your legacy, like some opcode optimizer, some opcode disassembly, and put that on the NeoCompiler Eco interface again. We currently have some projects that are written on C++. They are ported to the JS, like the big integer library that we use on the project, that some other people in other communities also use. We believe to start building these things on Rust as well, because we believe Rust it's a little bit simpler, and now it's attracting way more developers, like due to its simplicity and popularity. Is very popular now. So we believe some of the modules that currently we have written in C++ for NeoCompiler Eco, we can rewrite those in Rust, and also benefit the Rust community as well. And also we can support some other tools that exist, and some current projects like the decentralized file system projects, some native, explore more the direction of native contracts, like decentralized name services, decentralized identity projects. Maybe we can have some popular projects from Neo community to have some links directed to our native contracts tab. Not native, but popular contracts. We can also have some integrations like this. And we also are open to ideas for the community. So if you have some idea, feel free to share with us. And because this is a project for us, it's built for the Neo community. And we are the users and the developers, and it's something that is very important to us. So if you have some ideas, feel free to share. And from my side, that's it, Victor.
From my side as well, thanks, Sam, for the opportunity, and thanks for everybody watching this workshop.
Okay. So, Sam, do you have some questions, or is it some finished? I think
Sam,
the transmission, I think it stopped, right? Oh no.
I'm not sure.
Sam, are you alive? Your mic is not open.
I'll ping him on Discord.
Uh, let's start again. Será que tá transmitindo ainda?
Não sei, cara.
So,
de qualquer
okay.
maneira, eu acho que tá beleza, né? I think it's
Tá
okay,
bom.
né?
Vamos
Então,
cortar
bye
os
bye.
vídeos, então, e bye bye.
Aqui, very good, hein, Igor? Thank you.
Ok.
Falou, tchau, tchau. Valeu, valeu.